So when we graph piecewise functions, what we're doing is we're looking at this word piecewise, and we're thinking about, what does that mean, piece? Well, it means exactly what it is. Break into pieces. You're looking at a function that you're breaking into pieces, but why, Mr. Rose? Why are they different pieces, Mr. Rose? Well, they're different pieces because of different domain restrictions. Because of different domain restrictions, we're breaking up the graph into pieces. This is our first restriction. This is our second restriction. And furthermore, the function about these two different areas of domain
that one should be 2x plus
are different functions. Thank you. This should be 2x plus 3. You're right. They're different functions, right? F of x equals 4 and f of x equals 2x plus 3 are different functions. So this first graph is going to be of the first function. F of x equals 4, and that'll be my first step. Well, that's equivalent to y equals 4. That's the straight horizontal line at y at 4. That's this line right here. And I'm going to bold what the restriction does to it. So if my restriction then is, of course, x is less than negative 2, then the actual graph of this piece that we're looking at is at negative 2. We'll have an open circle because this is less than. We're not including negative 2. That's why it's an open circle. And less than is in this direction. Everything less than negative 2 for x. I make the line thicker there to show that it's highlighted. So the thicker line right here is the graph, the piece that we're looking at for the piecewise function. Next, graph f of x equals 2x plus 3.
not on the same graph.
I'm going to do it on different graphs to show the process, and then you can do it on the same one if you'd like. I'm just trying to make it simple for everybody to be able to conceptually grasp what's going on. Okay? So, this is, like I said before, y equals 2x plus 3. That's the same as f of x. Let me zoom in on this. I can zoom in. Make this a little larger. Now if I were to graph this, what kind of graph is this? It's a line. 2x plus 3 is a line. Where does it go through the y-axis? At 3. You know it goes through the y-axis at 3. And then you know that the slope is up 2 over 1. Rise over run. Up 2 over 1. Up 2 over 1. Up 2 over 1. It makes this straight line. Like so. But the bolded section that I'm interested in is based on my restriction. My domain restriction of x is greater than or equal to negative 2. That's restricting my x's, my domain. Okay? So if we look at the graph at negative 2, it's right here, correct? Think about it. the graph of this line at -2 is at -2. It's on this point. But if I'm looking for all the x's greater than that, it's the graph in this direction. It's this piece of the graph, this bolded section. But wait, I did the graphs separate. Your final product will be taking both of these graphs, this graph and this graph, the bolded pieces, and drawing them on one graph. Just the bolded pieces, because those are based on your domain restrictions. Okay? So this is the final solution. Down here. This is my first piece. At -2, +4, we have an open circle. 1, 2, 3, 4. And it's bolded to the left. And then the other bolded section at the solid point here at -2 is at -2, -2 down here. Because we're looking at x greater than or equal to -2, the starting point right here. It was you, Tanner? Okay. So we're looking at f at -2 equals -4 + 3. Oh, it's actually at -1. My graph is a little off, but this point right here is actually -2, -1, right? -2, -1. You see how I got the -2 now? Yeah. Okay. And then we're looking for x's larger. So larger, this is x greater than or equal to -2 is from this point on for the x's. And then it goes through +3 right here. +3 for the y-axis, and that's it. So this is your final solution down here. Taking the two pieces and putting them on one graph. They don't have to be touching. Sometimes they will, okay? Sometimes they won't. Sometimes they will and won't touch. This is it jumping around a little bit. So now you're going to be able to try out number 2. Okay, try doing it on your own. And just remember my steps that I did. I can leave up these steps if you'd like me to.
I already don't.
Okay, so if it's going to take me to do number 2, so for you, I can do number 2 as well. Just because it is a curve, it's not a straight line, right? It's a little different.
Well, it has restrictions on the domain.
Okay, so watch this. I'll do this separately, just like I did before. So this is number 2. F at x equals x squared negative x squared, x greater than 2, x less than or equal to 2. This graph is going to be my x squared. X squared is at 0, 0, and it goes up. Correct? And at 2, 1, 2, actually the graph should be at 4. So I'm going to, right? Okay, wait. At f of 2, it's 2 squared, which is 4. So at the point 2, 4, okay, following along so far? At the point 2, 4, which if I name as, I know my graph's kind of off because I just kind of sketched it really quick. But if this was my 2, 4, ignore my 5s. okay? If this is my 2, 4, then for x to be greater than 2, it's from this way greater than. So this bolded section is the only piece of the parabola I'm going to use. That's the piece. Okay? Right, because that's what the restriction, the domain restriction is based off of. So that's why you use 2 to find out where the graph is at that point, and then so you can find your piece. So then you can find the piece of the graph that you're actually going to use. The next one would be f at 2 again, because now we're still looking at the restriction, but now it's less than or equal to 2. But f at 2 is negative 2 squared, negative 4. You see that? Negative x squared, f at 2, negative 2 squared, that's negative 4. One of the biggest math mistakes is right here. When you plug in 2 for x, they think it's a positive 4, but this time it's a negative 4 because there is no parentheses with that negative. From there, you know that at 2, negative 4, so 2, 1, 2, 3, 4.
Other side.
2, my mistake, negative 4. You have a solid point. And this parabola, negative x squared, is a downward facing parabola, starts at 0, 0, and looks something like this. So if I bolded this, it would look like this right here. I bold that.
The whole thing, right?
The whole thing. That's my piece. That's my other piece.
Why would you choose that way? Why didn't it just be this one?
Because it was, this is x less than or equal to 2. So we're looking at 2, and less than is this direction. This is the homework. That worksheet, just this one page is the homework. So your final solution then is 2, 4, up. This is an open circle. And 2, negative 4. This is your final solution then.
Wait, why is the bottom one not an open circle?
Because it's less than or equal to. Or equal to. Yeah.